This is Linked Data Engineering, and this is lecture number 4, Querying RDF with SPARQL. In this part of the lecture, you will learn about SPARQL subqueries and SPARQL property paths. We have already learned how to query RDF databases with SPARQL and also how to create complex or even more complex queries. And now we will learn how to make even more sophisticated queries with these additional two constructs. First of all, subqueries. Subqueries means you have a query inside a query. So these are nested queries somehow. Look at the following example. What we want to do here is we want to select all authors, again from DBpedia, by whom they are influenced and all the influencers' notable works. Of course, this is a query which could be also answered without a subquery, but this is only to demonstrate how it works. So first of all, we have one part of the query, select all authors and by whom they are influenced. And this will be our subquery, our internal subquery. You see this here, select author and the influencer, where author is of type writer, so this means all authors. And of course, author is influenced by its influencer. And then we put another query around that where we also want to have the notable works of the influencers, which means we add another triple over here, influencer, notable work, work. Now you might ask, okay, I could also put these three graph patterns under one select statement. Why do I use these nested constructs? First of all, there is an ordered sequence how these SPARQL queries are performed, carried out and computed. Usually, the inner one is computed first and then the outer one is computed. So this means if you want to influence in what order your queries are carried out, and this might be important, for example, for performance reasons, then you are able to use these kind of subqueries. Another point would be, for example, you could use here in the inner query aggregate functions and could, again in the outer query, use another aggregate function on the already aggregated result, which is also something quite nice. And you could combine this, for example, with unaggregated variables. So here, in combination with the aggregation, you have several possibilities to work here. So point one would be subqueries are a way to embed SPARQL queries within other queries, of course, and to influence the execution order, therefore. And also, you do this by the results which are achieved first is by evaluating the innermost query. Let's try what comes out of this, or what will be the result of this query. So we click on the link and simply run the query, and you see here you have the author, for example, John Benville. I don't know that author. You have all these influences of John Benville, which are Arthur Köstler, Austrian author, Heinrich von Kleist, German author, or Henry James. And you see here then the notable works, for example, of Henry James. You have The Turn of the Screw, The Wings of the Dove, Daisy Miller, The Ambassadors. We had this already in the last part of the lecture. So you see this would be the result that you achieve. So these are so-called subqueries. Besides subqueries, another interesting construct are property paths. What are property paths good for? A property path is nothing else but a possible route through the RDF graph between two graph nodes. And you can express how this graph should work, how this graph should be constructed. For example, the trivial case would be the property path of length 1, which is simply a normal triple pattern. So the property is simply one property. But you could, for example, first interesting case, you could give alternatives. A property path could specify alternatives for a property. So in the same way, for example, like you combine a query with union, but here in the same property could be, for example, subsume two properties. Here, for example, you could say this is a property path where I say, okay, the property should be either title or RDFS label, and all this should be subsumed in one column in the result. So you then have books, and then, excuse me, sorry, the title of the books. And of course, the property that you are using is either DC title or RDFS label. Quite simple. And of course, you can also give more alternatives than only 2. Another one is you have a sequence and you have a path length which is greater than 1. So which means you specify a path of properties which should hold between 2 given nodes. Simple example here, for example, first we have X and X should have a mailbox, and this should be the mail address of X, and X should know somebody, and we want to have the names of all people who are known by that people. So X knows somebody, these people know again somebody, and then from them we want to have the names. So you see, this is a combination. Of course, you could also simulate this with a sequence of triple patterns, but here you can put it in one property path. And this, of course, would return then only patterns or only results of variable X and variable name of people who know X, who know these people who are known by X, and their name then. So this is a simple way to express these kind of sequences of properties with the help of property paths. Within these sequences, you are also able to reverse simple triples. So these are inverse property paths. How does this work? So for example, if you look at the first one here in the example, X has the FOF mailbox and then comes the URI of the mailbox. You can specify exactly the same by reversing the property FOF mailbox and then simply by switching subject and object. If you are using a reverse property, so you see this by this acute sign and then FOF mbox, and then this is read in the other direction. So not from left to right, but from right to left. This is an inverse property path. And then of course you can combine this to so-called inverse path sequences. So this is an interesting example. Look at that. This is an inverse path sequence. We have here X and then we have FOF knows, which means these are people who are known by X. And then we have a reverse FOF knows, which means Y are people who know these people who are known by X. So give you a short brief visualization of that. So these are the people who are known by X. So this would be that node. And now all the Ys that will be returned in there are the Ys who also know the same people who are known by X. And of course then, to exclude X from the result list, we should specify a filter condition which says X should be not equal to Y, which will be the result that is returned then in the end. So this is an example for an inverse path sequence. And we are looking here for people who know the same people like X knows. Another, and this is the most important property or most, let's say, complicated property for property paths, are so-called arbitrary length matches. So for example, if you want to extract an entire social network from a FOF network, then you can say, okay, I want to have X and I specify X with his FOF mailbox. And then I say, I want to know the names of all the people who are known by X and who are known by all the people who are known by 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 the people who know X, and so on and so on and so on. And this, of course, you can do, like for example, with a regular expression. So this means after the first property, you can use the plus sign, which means that part of the property path must occur at least once. You could also use a multiplication sign, which means either it occurs multiple times, arbitrarily often, or it doesn't occur, never mind. And then, of course, the result would be all which is then in the transitive closure of exactly that property. So if we look at that, Alice, for example, knows here somebody who is called Y1. And this would be then the name 1 of Y1. And then, of course, also all the people who are known by Y1 are looked at, which would be then Y2 and name 2. And of course also Y3 and the name of Y3, and so on until this chain somewhere stops. So these are arbitrary length matches. And usually also it depends on the implementation. Of course, care should be taken. If there are cycles, then of course the implementation of exactly that SPARQL endpoint should also be able to detect cycles. Sometimes in rather used networks, if you are using then property paths with paths of arbitrary length, sometime you will run or you will exceed some limitations simply because, of course, determining an arbitrary path of possibly indefinite length would require too much time. But this can happen. Try it out in DBpedia. You will see where the limits are. So these are property paths of arbitrary length. And then, of course, you can also negate property path, which means you are looking for two nodes or structures within your RDF graph where two given nodes x and y are not related via exactly the given path. And the given path then could be an inverse path sequence, could be an arbitrary length path sequence, anything else. But you can negate it simply by using here the negation sign in front of it. And then in parentheses you specify the given path. These are the possibilities that you have with SPARQL property paths. We have here a simple example of a property path expression. What we want to find out here in the example is we want to know who are the authors who were influenced by the influencers of Jules Verne. So this is a simple property path expression. It's not of arbitrary length. Simply we are looking for influences and their influences, so authors who are influenced by the influences of Jules Verne. So length 2, quite simple. Let's have a look at the query here. So we want to select those who are influenced by the influences. Therefore, we also name the variable in that way from DBpedia where. So first of all, Jules Verne should be influenced by somebody. And now we are looking by those who have been influenced by that one. So influenced by influencers. And this is reversed. So this is inversed, reversed. And of course, then we have a filter condition that we do not want to have Jules Verne among the result set. So therefore, all the influenced by influencers should be all but not Jules Verne. So who is influenced by the same people like Jules Verne? Just look here at the SPARQL endpoint to run exactly that query. And then you see, there are interesting people. For example, Emilio Salgari, Italian author who has written lots of adventures like Jules Verne 2. Maybe we see another one who you know. Oh, Henry James is also among the list. Joyce Carol Oates, contemporary author. Ambrose Bierce, possibly you have heard of him, or Wolfgang Holbein, also a science fiction author. So it's quite interesting to see here authors who are influenced by the same people like Jules Verne. So possibly they might be also of interest for you. You see how or where this could lead. This could lead, for example, to some kind of a recommender engine of things which are quite similar. So you can use a knowledge base like DBpedia, a huge data repository like DBpedia in connection with the power of SPARQL to build a simple content-based recommender system. That's quite an idea, isn't it? Okay, so this is what you can do with SPARQL property paths. In the next part of the lecture, you will hear about the SPARQL endpoints, which are SPARQL databases or RDF databases. How is RDF data organized and accessed in a SPARQL endpoint? There are several possibilities. This we will talk of in the next lecture.